In this video, we're going to be talking about significant figures, which are an important part of both math and science and used in important calculations like lab work. However, to be used further in math, we need to know certain rules and regulations to be able to count significant figures in digits. This video is going to go through the different rules and then go through further practice examples to know how to count significant figures and make it easy for you. So without further ado, let's get straight. The first rule we need to discuss is essentially the easiest rule, and it counts for non-zero digits, and that is that all non-zero digits are significant. This means that anytime you see a digit that is not a zero, so 1 through 9, you can automatically say, okay, that is significant. That is because if you're measuring, a certain value and you measure 1 through 9, we can tell that, okay, you've measured that value and you've given a specific digit to that measurement. So in these examples, we can see for 528, there's 3 significant figures because there's 3 non-zero digits there. And then in 12,345, every digit in this number is a non-zero digit, so that would mean 5 significant figures since there are 5 digits that are all non-zero there. The second rule starts to deal with zeros, which can get a little tricky. But this first rule is that all zeros that are between non-zero digits are significant. This one is fairly easy to recognize. As you see in these examples, we have 50,005, and you can see that there are 3 zeros that are all in between 2 non-zero digits, 5. Because these 3 zeros are in between the 5s on either end of the number, we can count all 3 zeros as significant, and therefore there will be 5 significant figures. In the second value, 2024, we have 1 zero that is in between 2 non-zero digits, the 2. Once again, since it is between these 2's, we count this 0 as significant, and therefore all 4 digits in this number are significant, leaving 4 significant figures in this number. Rule number 3 for significant figures is that leading zeros, also known as placeholders, are not significant. A trick that you can use that's quick and easy and can help master this rule is that don't start counting significant figures until you reach a non-zero digit, because that means all those zeros leading up to non-zero digits are not going to be significant. So essentially what you can do is just don't start counting significant figures until you see a non-zero digit. So let's apply that to these examples. In this first one, if we don't start counting significant figures until 0.442 right here, we can see that there's only 3 significant figures, the 4 and the 2 2's. These zeros here in the front are non-significant because all they do is they act as placeholders leading up to those final digits that are significant. Again, in this last example, we have 0.095. Same thing here. If we don't start counting significant figures till the first non-zero digits, we have 0.95, and there we can have 2 significant figures for this particular number. The next rule for significant figures deals with trailing zeros instead of these placeholder zeros. So trailing zeros are going to be zeros that come after all non-zero digits. In this first rule, this is where, especially with zeros, it starts to get a little tricky because you have 2 different scenarios where trailing zeros are or are not going to be significant. This first rule states that trailing zeros after a decimal are significant. So for this one, you can kind of differentiate by saying, okay, if I see any zeros after a decimal place, boom, they are significant. So let's look at these examples here. First one, we have 25.00. So we have the 25, but then you have these 2 zeros here right after the decimal. Those 2 zeros, since they are after the decimal here, they will be considered significant. Therefore, this value will have 4 significant figures. And in this bottom one, same thing here. We have 349 and then 3 more zeros after the decimal place, which would make 3 significant figures in the front because of the 3 non-zero digits, and then all 3 of these zeros are significant, so then you will get 6 significant figures here. This next rule also deals with trailing zeros being significant, as now we have trailing zeros before a decimal are significant. Another way you can think of this and make it really easy is for both rules dealing with these trailing zeros, if you have a decimal place, any zero, both before and after the decimal, are going to be significant. However, when using that method, you have to remember that if there is a zero, let's say before or after the decimal, that is before any other non-zero digit, then it will not be significant because it is a placeholder. So you do have to remember that and not get tripped up over that rule as well. So essentially, if the zero is after a non-zero digit and it is before or after a decimal, you can consider it to be a significant digit. So let's take a look at these examples. This one is really helpful in kind of seeing this rule in particular. So as you can see, we have 750 with no decimal place. So in this example, we are not really measuring out as precise as, let's say, this one below. So you have 750 with the decimal place. And by putting that decimal point there, we are saying that we are measuring out to that decimal place, and therefore that makes that zero significant, while this zero up here will not be significant. So this top number will have 2 significant figures because that last zero is not significant with no decimal, and this one will have 3 significant figures because of the decimal point before that final zero. This rule regarding trailing zeros is the scenario in which trailing zeros will not be significant. So the rule is that trailing zeros without a decimal after are not significant. So if you had a series of non-zero digits, like in this first example, we have 22,500, you can see that there's the 225 and then there's those 2 zeros after. Because there is no decimal place after the 2, 2, and the 5, these 2 zeros here on the end will not be significant digits, and therefore the last 2 zeros here in this number are not significant, so you will have 3 significant figures in that first example. But then when you look at a number with that decimal place at the end, let's say 3,200, when this decimal place is inserted here at the end there, then you can see that these 2 zeros here at the end are going to be significant digits, even though there's no digits after or anything like that. Because you have that decimal after those zeros, trailing zeros, it is going to be significant, and therefore this number has 4 significant figures. The 7th and final rule regarding significant figures, and in this video counting significant figures, is that when in scientific notation any given number, measurement, only pay attention to that first value given and disregard the exponent there at the end. So what I'm saying to disregard is this 10 to the 4th right here. So why I say disregard that is because all you need to worry about is this first number here, this 5.05. This is because that 10 to the 4th here is actually just multiplying it by 10,000, which when you multiply it by that value, it is not changing the significant figures, because if you had that 505 in a number, the 5 would be significant, the 0 would be significant because it's in between 2 non-zero digits, and therefore you would still have 3 significant figures despite all of the trailing zeros after. So this is why this number will have 3 significant figures. Now that we've gone through these rules, we're going to go through a quick list of different practice problems and really look at a bunch of different rules and applying all the rules at once so we can really get it down and get a strong confidence in these rules. So without further ado, let's get straight into these examples on counting significant figures. So here we have 10 practice problems with all types of different numbers and using all the different types of rules that we have learned so far in this video. If you want to, you can go ahead and pause the video before I go ahead and explain the answers to each of these 10 questions. Okay, so looking at this first example, we have 5.40. This number is going to have 3 significant figures because we have 5.4, which both are non-zero digits and they will be significant, and then we have a trailing 0 after the decimal, also after that non-zero digit, and therefore that last 0 will be significant and there will be 3 sig figs. To 10, however, there is no decimal in this one for number 2, so we will only have 2 significant figures because there's no decimal to make that last 0 significant. For number 3, 801.5, that 0 is between 2 non-zero digits, and therefore that will be significant. So as a result, we will have 4 significant figures for number 3. Number 4, we have just straight up 1,000, and this is only going to have 1 significant figure, and that is because all 3 of these zeros in the back, there is no decimal to make them significant, they're not being measured out to, and therefore just 1 significant figure for number 4. Number 5, this is interesting. Actually, looking at this, every single number in this number, every digit in this number will be significant. So this one is going to have a whopping 7 significant figures. Now, why is that? So this first, obviously all 3 of the ones will be significant, but you can see this 0 here in the middle between these ones. Since it is between the 2 non-zero digits, we know, okay, that is significant. But then we have also another 0 after the decimal, but it is also between 2 ones. Boom, that one's significant. And then these last 2, it is after the 1, and it is after a decimal. So these zeros here at the end are also being measured out to. So those are going to be significant as well because, yes, they are trailing zeros, but they are after that decimal. So they will be significant in the end. So 7 significant figures for number 5. Heading on to number 6, this is where we have scientific notation. So remember, you can just totally get rid of that, and we see 1.2, so therefore, boom, 2 significant figures there. Number 7, if you remember the rule about those placeholder zeros leading up, just wait until you see a non-zero digit, and that first non-zero digit is the 1, and then therefore 2 0, so there will be 3 significant figures in number 7. Moving on to number 8, it's very, very similar to number 7. We have those 2 placeholder zeros starting out, so those are not going to be significant there. But then you can start counting. Remember, start counting at that first non-zero digit, which is 1, and then we have 102 left over, and that 0 is in between 1 and 2, so that will be significant. So number 8 will also have 3 significant figures there. Number 9, we have another scientific notation, but once again, same rules apply. We have 10 to the negative 6. Let's just mark that out. We don't have to worry about that. We have 9.010. So in this number, we have the 0 in between 9 and 1. Yes, that's significant. And then the 0 after the 1, but it's after a decimal, so that is a trailing 0 that will be significant. So every number in that first sequence, 9.010, is all significant. So number 9 will have 4 significant figures. Final question, number 10, we have 2370.0. That decimal really just totally makes this whole question what it is. And as you can see, since we have that decimal, that trailing 0, both of these trailing zeros here are going to be significant both before and after, since they're after non-zero digits, and now with that decimal, both before and after will be considered significant. So number 10 now has 5 significant figures. So that wraps up our practice for this video. I hope this was helpful in really being able to master counting significant figures, because once you can count significant figures, it will really help you when doing math with significant figures, whether that's in labs or other things like that. So I hope this video was helpful. Please feel free to leave a comment down below with any other really just subject matter, whether that's math or science, just anything STEM related. Just leave a comment. If you're having trouble with it or you just want to learn more about it, leave a comment and I'll do my absolute best to make a video over it and really just explain it fully in depth. But I hope you enjoyed the video. If you like it, just leave a like below, subscribe if you want to see more videos like this, and thank you.